I didn't feel too well this week, and therefore I didn't have too much energy to start a new project. But I'm sure some of you, or maybe even all of you, will be familiar with this. This is my trusted Heathkit IG-102 RF generator. Now, honestly, what I'm going to do now, I've been putting off and off and off for weeks, if not months. But I thought, well, since I'm not feeling too good, I can take on a smaller job. So I started to hook up my frequency generator up to my frequency counter, which you see over there. And I started to check each of the bands you see here. So let me remind you that the Heathkit IG-102 goes from, at least theoretically, 100 kilohertz all the way up to 110 megahertz. Now, to be honest, once you're past the E band, which is up to 32 megahertz, the Heathkit doesn't really hold up very well. So in other words, it becomes wildly inaccurate once past the E band. But, this is a perfect tool for doing alignments of AM radios and even FM radios. So I'm not too worried about its inaccuracy above 32 megahertz. In any case, what I was thinking is that if you take a close look at the divisions of each of the bands, you'll notice that it's subdivided in either 1, 2, 3, 4, 5 parts, or in 1, 2, 3, well, actually it's subdivided in 1, 2, 3, 4 parts, around the 200 kilohertz, for example, if we talk about the A band. Yeah. So I thought, well, it must be possible to get the accuracy of my IG-102 such that I can dial in a quarter, or rather half of a subdivision, yeah, and still be reasonably accurate, or still have it be accurate reasonably, even if I dial only a half of a subdivision. Now, unfortunately, it turns out that my Heathkit IG-102 is not accurate at all. In fact, it diverges by more than 100 kilohertz on the lower band, and that quickly rises up to 2 or sometimes even 3 megahertz when I go into the higher bands. Well, particularly if I go into the F band, then it becomes wildly inaccurate. Which is kind of a shame, since I like this instrument. It's simple to use, it's straightforward, and it doesn't have too many parts. So servicing it, should I ever need to service it later on, is not too difficult a job. Now, you might say, okay, what could be the reason for this, for the blatant inaccuracy of my Heathkit? Well, I've been measuring all the passive components inside of it, the capacitors you see here, so these ceramic caps and some paper caps, and the resistors, which are, by the way, all carbon type resistors. And well, except for a few exceptions, I mean, for example, for the resistors, there are perhaps 2 or 3 resistors which are within value, let's say less than 1 or 2% divergence from their intended value. All the other resistors are at least 15% off. So if we talk about a 100k resistor like the one over there, this one here, yeah, this one measures 115 kilo ohms instead of 100 kilo ohms. So that's a divergence of 15%. And that's a lot. And there are other resistors in here which even diverge up to 40%. So, you know, my first reaction is, well, no wonder my Heathkit is not performing too well. Strangely enough, when I just got it, it was still running reasonably well, although already then it started to diverge from the dialed frequency. So it must be that by using it over the weeks and months, the resistors and capacitors have steadily been growing bad, which is kind of sad. But, well, you know, those old electric components are notorious to fail after a certain point. So what I'm going to do, since it's not too heavy a job, is I'm going to start by replacing all the carbon resistors and all the obvious bad capacitors, and then I'm going to connect it up again to my trusted frequency counter and check it again. And my guess is I will probably have to do that a couple of times until I am satisfied that it is working reasonably accurately. So I'm calling this episode unofficially, that is, the Heathkit IG-102 Revisited. Okay, I finished replacing some of the resistors and a few capacitors, which definitely were beyond their intended value. What was a stroke of luck, you could say, was the fact that I was able to replace the capacitor, which was originally here and which was a 4.7 picofarad, or as it is written on the schematic, microfarad, but as we all know, that's picofarads. So I had a ceramic 4.7 picofarad on hand, imagine that, and that's a pretty rare value to have. Anyway, I also gave the whole function generator good cleaning. I replaced all the obvious resistors that were not good, and well, then I switched it back on and hooked it up and to my frequency meter, and you can see it over there. Now I'll show you something which is really weird. Now, okay, so don't pay too much attention to the value you're seeing over there. The frequency meter is telling me that at this stage my frequency generator, my RF frequency generator is outputting about 454 kilohertz, which unfortunately is at the end of the scale right now, well, on the A band anyway. And actually it should be outputting at this stage or at this level 320 kilohertz. So it's off by at least 130 kilohertz. But now here is the strange thing. If I turn down the function generator frequency, then indeed the frequency drops on the meter too. Now I keep dropping and dropping and dropping, and what do we see? The frequency starts to rise again. Okay, granted, it doesn't rise to the previous highest level you saw just a few minutes ago or a few seconds ago, but it still rises. Now I keep turning the button down, and now the frequency jumps right back up again, and I keep turning the dial knob. You see, it still rises and rises and up, and now I get beyond a certain point and the frequency starts to drop again. So you can see that I'm turning down the frequency, and you can see on the meter effectively the frequency is now dropping, and now it rises again, and now it drops again, and now it keeps dropping for a while. Well, actually it stays rather at a stable frequency of 365 kilohertz, and I keep dropping the dial knob, and now the frequency stays actually it starts to rise a bit again at the very end of the dial. So yeah, I'm getting a very weird effect on my function generator, and I'll be damned if I know why that is. Frankly, I'm stumped a bit for the moment, because well, it's a damn weird phenomenon. Now I tried to align the frequency coil for the lowest band, which is this one down here, and although I could vary the frequency by about, say, 700 kilohertz, I never quite managed to drop the frequency down to 100 kilohertz, which actually it should be, at least if the dial knob is in the position it is right there, yeah, which is a completely closed tuning capacitor. So yes, this is a very weird effect, and well, like I said, I'm a little bit stumped. So if anyone out there, if any one of you have an idea what the cause could be for this rather strange fluctuating of the output frequency, then please let me know, because right now I really have no clue what could be the matter. So there are only just a few more capacitors to replace, and then I'm quite done replacing parts. So, well, if I really must keep on changing parts, then the only parts that I could replace are either these parts down there, which are the power supply parts, but they work fine. The diode is fine, the resistor is fine. I also replaced the electrolytics, as you recall from the previous series, so that all that is fine. So really, what I'm confronted with is an alignment problem. Actually, is sort of a tuning problem. Now that the tuning capacitor looks in fine condition, it's clean, so I don't think the tuning capacitor is the issue here. I think the issue must be either one of the capacitors I still haven't replaced up here, but those are ceramic capacitors and those rarely go bad. So then it might be one of these ceramic capacitors down here. That might be the culprit, perhaps. Or there's one very special little capacitor up here. Now, I checked on the schematic, and if I read the schematic correctly, this should be a 2.2 picofarad capacitor. And well, I don't have a 2.2 picofarad capacitor, so that's a bit problematic. So yeah, it's mixed. It's a mixed result. I really have no clue what could be the problem. But it's getting late and I think I'm going to call it a night. So I'm going to continue the update either tomorrow or the day. Okay, I finished replacing most of the parts. In fact, well, except perhaps for 2 resistors that were still within spec, and maybe 2 or 3 capacitors, I changed all the parts. And this time, instead of using my frequency meter, I used my scope. And the result is much better, as you can see on the scope. If I connected it up, I connected my scope up to the output of my frequency generator via a BNC connected cable. You know, you see it like that, and it's on channel 1 of my scope. Now, as you can see on the scope, the frequency is off by just say 90, let's say 3.4 kilohertz. 3.4 kilohertz, which is not too bad actually. So, what I'm going to do to finish my frequency generator off, well, to finish it off would be to kill it, but to finish refurbishing my frequency generator is to try to align the coils. And to do that, I'm going to take one of my alignment tools, which is those special plastic core turners I bought. Yeah, there you go. Oh. Hang on, I'm taking it out. And I'm going to gently try to align the coils so that the frequency gets closer to 100 kilohertz. So I insert it into the coil. Actually, I'm going to try to insert it into the kernel which is inside the coil, and then I'm going to turn the coil so that the frequency gets higher by just a little bit. So, just to show you, the higher frequency should go more into the left, as you can see by my cursor lines. Yeah, so if I move the cursor line inside, yeah, it means that the frequency gets higher. So I'm now measuring from one peak to the next, and that is, if I'm not mistaken, one full wave. Okay, so we're at 96.6. Okay, but before I continue, I'm going to mount the camera on the foot so that you can follow what I'm doing without seeing, and I have my both hands free for showing you what I'm doing. Okay, hang on. There you go. Okay, the foot is on the camera. Okay, so there you go. You have a good image of the scope. So what we're going to do now is we're going to align the core and see whether it makes any difference in frequency. So let's go. Oh yeah, it is making a difference, only slightly so, but let's see. If I turn this up, I am close. I am close to getting 100 kilohertz. Okay, let's go. A little bit higher. Just a little bit. Like this. And then adjust my cursors, which I'm going to do. And I should turn it up a little bit more, perhaps. You can see a slight movement, yeah, but the thing is, okay, it's only very slight adjustments, but we're getting close. We're getting really close. Okay, we're at 99.5, so I should raise it a little bit more. Okay, that moved a little bit, so let's readjust the cursors. Uh, 99. Well, let's raise the frequency just a tad more. Okay. And I think we're spot on. Nah, maybe I'm a bit too far. Okay, so let's turn it back a little bit. Okay. And I should be close to... Ah, there we are. Yeah, and I think if you watch it closely, I think I'm right on 100 kilohertz. Okay, so now we're going to move the dial up to, say, halfway to 170 kilohertz. Okay, there we go. Okay. This is 170, or at least that's what the dial says, you know. As you can see, it's on the position 170. Yeah. So it's the highest scale closest to the pilot lamp. Yeah. So it's set on exactly 17. Yeah. So that should translate to 170 kilohertz on the scope. So let's see if that is what it is. Let me see, where are my cursor adjustments here? Okay. So it says 172, but let me see if I align it with the grid lines of my scope tube, and then I align my cursor lines exactly with the scope lines, the grid lines on the scope. So yeah, we're off by 2 kilohertz. Okay, so let's see if I can readjust it a little bit, but like this. So, and you can see that the frequency is a really nice sinusoidal signal. Yeah. So yeah, I'm off by 1 kilohertz. So let's readjust it a little bit. Just a little bit. Okay, like this. So it's a very nice sinusoidal signal. So I'm astonished really at the quality of the signal. There is no noise to mention, and yep. And we are exactly, well, we're, I don't know, we're pretty close to 170. So I think I should increase the frequency just a little bit, and then we're close. By the way, the sounds you hear on the background are from the movie To Have and Have Not with Humphrey Bogart. And I seem to work quite well with that on the background. Okay, 170. Perfect. So now let's move the dial up all the way up the scale. So I remind you, I am on the band A, and that means that the maximum frequency is 320 kilohertz. So that would translate to a position at the marker 32 on the A band, yeah, the ACE band. Okay, so let's move up the selector to all the way up to 320. 320 is just there. Okay, so let's have a look. Dial up the frequency divider up. Okay, now let me see, I need a little bit more brightness. And that will do. Okay, so the signal is rather faint, but then, well, and you can see there's a little nick in the signal down here, you know, where I'm pointing. So down here at the bottom of the signal, there's a little nick, and that's because the signal isn't at a higher frequency, is not too pure, but that's okay. So anyway, we should have now 320 kilohertz. So let's see, I adjust my cursor lines, and from peak to peak, and let me see now. It's more 315 kilohertz than, it's more like 315 kilohertz instead of, let me change the, adjust the focus so I get a sharp image. And let me see if I dial down the illumination of the grid to very, very low. Okay, now we get a much, much better view of the signal. Now let's see if I adjusted. We're off by about 4 kilohertz at the highest scale. Okay, I'll see if I can adjust for that, compensate later on. I'll remind you that this is a tube apparatus, and all tube appliances need to heat up before they stabilize. Now, let's go to the B band. Now the B band goes from 310. So I'm going to dial 310. And the B band is this scale. So there you go. And 310 is over here, okay? So this is 310 on the B band. So I set the dial selector to 310. Okay, so we're from on the scale, we're on the scale from 310 to, hang on, oh, I need to trigger the signal. There you go. Okay, so now we're at 310 normally. So let's see if that's correct. So let's set my cursors. Oh no, I can already tell I'm off by quite a bit. This should read 310. And it's actually reading 293. Okay, so the frequency is off by quite a bit, so let's adjust that Okay, so I put it in the second core. There you go. Oh, and by the way, it's a hexagonal screwdriver I'm using, and it's plastic, like I said. So let's put it into the second coil, which is this one over here. So, and let me wiggle it into the core. Okay, so we need to raise the frequency to 310. Okay, so the two peaks you see on the screen should move towards each other. So here we go. Yeah. Okay, so now I adjust my cursors again. Okay, we're at 299, so let's move it closer yet. And you'll also notice that the higher the frequency gets, the lower the amplitude. Theoretically, my RF generator can go all the way up to 110 megahertz, as you can see here on the band switch. Well, if I display the signal on my scope, hang on, I'm going to give you a close-up of it. I'm attaching the foot to the camera so that you can have a stable view of the whole thing. There you go. Okay, so as you can see, the frequency is off by about 2 megahertz. Yeah. So, which is unfortunate, of course, but it's as accurate, I think, as it could ever be. I don't think I can make it more accurate than this. So, on the highest band, the RF generator has a frequency error of about 2 megahertz, maybe a bit more, maybe a bit less, but I'm on the highest, or I should say the smallest time division on my scope, and my scope can go up to 150 megahertz, but this is about as high as I can go on my scope. So yeah, it's difficult to tell. I think this is a case where perhaps I should switch over to my frequency counter. But anyway, on the scope, I would say it's off by maybe 2 or 3 megahertz on the very highest frequency my RF generator can generate. So anyway, the result is rather good. Now, I think one of the reasons why at first I couldn't get my RF generator to generate a normal high frequency was that I had not replaced, I had not replaced some of the parts around here, this part of the RF generator, this lower part here. Now, I think by replacing 2 capacitors and or 3, I should say, you see one here, then you see this one and then that one. By replacing those 3 capacitors, my RF generator suddenly started to work a lot better. And then I did the same thing. I replaced these 4 capacitors, so this one, that one, that one, and that one, with new ones. And oh yeah, no, 5, I replaced this one too. And then everything started to work absolutely perfectly. So all I needed to do was just to realign the kernels inside the band coils, and well, there you go. That was it. I replaced the electrolytics for the power supply already months ago, so I knew I didn't have to look at that. And I also gave all the switches a good thorough cleaning with contact cleaner, and now they work perfectly. The only thing that doesn't work quite well yet is the attenuator. Now, normally if I dial down the attenuator, you see, it works pretty good, yeah. But that is only when the attenuator is at high scale. So let me show you. So the coarse attenuation is on high level right now. And when that is on high level, the fine attenuation works reasonably well. But the problem is that it's only the first, say, 1/3 of the scale that works. Yeah, so from highest till about here. Yeah, and then it stops. But I have all of this still left, and that simply doesn't seem to work. Not at all. So now, if I put the coarse attenuation on medium, yeah, I still have the same problem. Yeah, and now the travel of the potentiometer is even smaller. Yeah, also, the more I turn the potentiometer down, the more distortion I get on the signal. So, well, yeah, and on the low coarse attenuation, I don't get anything at all. Nothing at all. Just garbage, noise. So, actually, the attenuation doesn't work very well. I might have to, well, either replace the resistors you see over here, so these resistors here, or perhaps I might even have to replace this potentiometer. Either way, the attenuator doesn't work very well, so I'm really not pleased with it. And oh yeah, there's still a capacitor over there too. So I might have to replace those parts to make my frequency generator work. Now, I did my best to align these coils you see here to give the best possible performance. And, well, depending on the frequency band, the precision with which the frequencies are generated varies between, say, 1 kilohertz for the lower bands up to about 1 megahertz for the highest, the very highest band. Now, if you divide the output frequency by the error you have in output, yes, say for the lowest band, the highest frequency is 320 kilohertz, and the divergence or the error on that output frequency is 1.2 kilohertz, that makes it about 0.3% error, which is really, really low. So, well, especially if you consider that for electronic parts, often there are error percentages of 10%, 15%, even up to 20%, then an error margin of 0.333% is really not that bad. Also, the error on the highest frequency band is about 1.2 megahertz on the very highest frequency, which is supposedly 110 megahertz. Now I say supposedly because apparently it had no trouble kicking out 111 megahertz. Anyway, the error percentage on that is about, well, if you divide 110 megahertz by, say, 1.1, 1.2 megahertz, is still only 1%. So actually, the accuracy of this very simple RF generator is really not too bad at all. Now, I did notice that it really needs to heat up before it starts to give a rather stable frequency. So it really needs to heat up for, say, 2 or 3 minutes minimum, and then it starts to become really stable. Okay, enough of that. So I was stumped a bit by that bizarre phenomenon that when I started to refurbish my RF generator, that it outputted first a low, then a high, then a low, then a high frequency again. But it must have been a faulty part. And in fact, one of the parts I hadn't replaced yet. But rather than start and look exactly which part did it, and I can tell you it probably wasn't just one part, but probably 2 or 3 parts together that created the error, I just went for it and replaced all the parts that were either not looking good enough to me or that didn't measure good enough to me. So the original parts you see inside the cabinet, there are still a few. This one, this capacitor here, that one over there, and this tiny one over here, which by the way is 4 picofarads. And then a couple of resistors, carbon type resistors like this one or that one, they measured out fine. So I left them in. You know, I mean, they really measured fine. I mean, this one, for example, orange, white, brown, is supposed to be 390 ohms, and it measured out as 402 ohms, which is really a very low error margin. So I said, well, you know, why replace it if it's still good? And anyway, if the whole device starts to go bad again, then I know I should have a look first at the original parts which are still in the cabinet. Anyway, what I'm going to do now is I'm going to reconnect the fuse holder you see down there in the cabinet back to the power supply of the Heathkit, and then I'm going to close it up again, and I'll call this project, this one episode project, as done. And there you go, the Heathkit IG-102 reassembled and ready for use. So from now on, realigning radios will become a breeze. So thanks for watching and stay tuned for other updates. Bye.